Alright guys, so last week I made this drawing robot here, and while it does work, there is still quite a bit of room for improvement. So my goal for this week is to try to find all the bugs that it currently has and try to fix them. If you guys remember back to last week's video, I did some testing on this drawing robot, and I found a weird bug that when you'd go down a certain distance, it would start to go back up, even though it was thinking it was going down. This happened in all of the directions, not just down. Now, it originally started happening on this servo-based bot, and I thought it was maybe the servos that were causing it. However, when we moved over to using the stepper motor bot, it started doing the exact same thing, which leads me to believe it's probably the math. So I decided to go back to the drawing boards and figure out how all of this works. These here are just all the different functions that we're going to be using. And this right here is the actual math that's going to be used inside of the drawing robot. Now what I did was I took this, added it into a Python file, and then compared it to the code that we were using inside of the robot. Now, as you can assume, it's basically the same thing, and so it works about the same for the most part. However, there are some areas where I noticed you enter in one point, and then the two different functions will give you two different results. Now, by just using common sense, it looks like the function that I made is actually seeming to work better, but I'm not entirely sure yet. What we've got to do is go and translate this over into C++, which we can then use to upload to the robot and test it in the physical world. And so my first goal is to try to do that. All right, I got it figured out. Turns out I just had the wrong symbol, so it should work now. But let's see what it does. I don't know what it's gonna do. So let's try going down. What the heck? Okay, well, I tried to go down, but then it started going back up, and it seems like the problem started even sooner than before. Oh, and the problem like that just clicked again. Why is it doing that? All right, guys, so I did some more digging, and I believe I figured it out. So in the code, I have the lengths of each arm segment. For example, this one right here is called L2, and this one right here is called L1. Same for this side. Now to make the process of writing this code a little bit quicker, I actually copied and pasted over the code from this robot right here, and I forgot to change the arm lengths. So this robot was thinking that its lengths were the same length as this robot right here, and for some reason that was causing the error when it got down here. So I went ahead and updated that, and now if we move down, you can see it gets pretty dang far. That's basically homing point. If we go all the way up here, you'll see it in just a second. So right here, it's about to breach it. Basically, it goes like that, boom, and slams back. Well, basically it gets a little too far and gets to an actual point that's unreachable. So anywhere this zone right here is unreachable, and that throws an error up on the computer side of things. And for some reason that just causes it to get stuck in a loop of spinning. What we've got to do is be able to catch the error before it even happens, and then make it so the computer won't even try to go to that point if that point ever shows up. Now that is a pretty big problem solved, and we can see here I can actually start drawing. Now the line is still super wiggly, I guess you'd say. However, it does seem to be pretty straight. Like, let's go straight like this. Actually, a good test would be causing it to go in a loop of drawing a rectangle. So let's see that. Okay, so that's interesting. That's what it looks like there. This is one that I had to draw last week, and this is one we just drew just now. Crazy, because I'm pretty sure that's like the same code, so I don't know why it's drawing a different shape, but whatever. However, I think we've solved the arcing problem. If you see on this one here, this is the old setup. It would arc like that, which is really weird. This one here, it is still veering off, but it's not really arcing too much. That seems pretty straight. That seems pretty straight to me. Same with that one. There might be an arc that's happening. It's hard to tell. I'd have to let it draw for longer. But this one here, you can clearly tell there was some sort of arc going on. So now that we've got the math problem sort of figured out, I guess, what I want to try to do now is make a new version of this and reposition a few things. Right now we have our limit switches right here, which that's okay. It makes homing really easy. We know that this is going to be 0 degrees and that's going to be 180 degrees. However, as you can see, this thing is getting caught in the middle right there. And some angles, like angles close to this thing right here, we can't actually reach because of the limit switch being in the way. So what I think we need to do is maybe move the limit switches over to the back here and have this thing be able to go all the way down here. Then we'll have a little bit more drawing room here. As for this middle part here, I'm not entirely sure. I think what we're gonna have to do is home one side and then move it up, and then home the other side and then move that up. And then we'll know where they were, I guess. And then we could move it to a specific point. That sounds a little confusing. You can also see in this picture here that it is moving to the side a little bit. Now, I believe it's doing that because the way I have it set up right now is it's reading the step angle and then calculating how many steps it's gonna take to get to the angle or to get close to the angle it should be at. Now, it never actually gets right to the angle. It's slightly off. It could be off 1 degree, fraction of a degree. It changes every single time it does the calculation. And I believe that slight offness is causing it to do this right here, where it just slowly moves. Anyways, what I'm thinking of doing is adding one of these right here. This is a magnetic encoder. Now, I originally avoided adding this and added my step setup because this is a little bit more complicated and it takes a few more wires. However, with this, we can actually read a precise angle of the shaft. What I think I'm gonna do is still have my step set up. However, it's going to also check where it's currently at and then decide where it should be and then figure out how many turns it takes to get there. And it'll be just doing this constant recalibration every time it moves. That way we shouldn't end up with something like this. So I'm gonna go ahead and try to figure out how I'm gonna even design this thing. All right, guys, it's finally put together. This thing took way longer to put together than I originally wanted. My goal was to have this done on Tuesday and it's now Wednesday. We burned up an extra day because of this thing right here. This is a little I/O expander. Basically, it just allows us to have more pins that we can use to plug extra stuff into our ESP32. I spent all of yesterday trying to figure out how to get this dang thing to work, and turns out it was super easy. I just had no ground connected to it, and also my I2C pins were plugged in on the wrong side of the ESP32. So we ended up burning today messing around with this. However, we did get it in and all figured out. It's super easy how it works now. Now this new version here has magnetic encoders under each motor right here, which means we can tell the precise angle that the shaft is at, which is a lot better than the old design since we were just basically counting the steps and hoping we were right. Now we still have the same pen mounting system right here. I want to add a servo to this and make the pen go up and down when we tell it to. However, I didn't have the time for it right now, and so we're just gonna have to rock with this for a second. But since this thing is all put together now, I want to go through and individually add each component into our code and test to make sure that it's working. So we're going to start with adding in our limit switches and seeing if those work. All right, this is limit switch test. Let's see what happens here. Those shouldn't have locked up. That should not be on. Let's see here. Let's turn it off, turn it back on again. Okay, that's weird. Let me change a few things. All right, so I fixed the code and it should work now. Now, if we keep an eye at that LED over there, it's kind of hard to see, but it should turn on as soon as this limit switch is hit. No, okay, interesting. Let's try the other limit switch here. Should turn on as soon as it's hit. No. What the heck? Oh, now it's on. Hold up. Wait a second. Let's see. Let's plug it. Let's unplug it and plug it back in. Is there a loose connection here somewhere? Here, let me try some more crap. All right, so I got it figured out. Now when you press this, you can see that light over there does light up a little bit. Same with this side over here. You can see here, this is what the serial monitor says. So this is the left side, and then this is the right side. So yep, limit switches do work, and the I/O extender works. I did have to swap it out with an old one to get it to work for some reason. I don't know why. This one was like messed up for some reason, so it's all right. That does work now. That's good. These work, so that's good. So we already have it connected up to my computer. I want to see if I can get the encoders to work. That way we can start measuring the shaft angles here. So I'm gonna get that set up real quick. All right, guys, I got the encoders set up here. As you can see, I'm moving the arm right here, and you can see the left motor angle and the right motor angle right here. If I just leave them still, they just kind of hover around that area. They do seem to flicker a little bit, but it doesn't look to be too much, so I think that's gonna be just fine. Now, we need to still test the actual motors moving. However, we kind of need to get everything else set up as well to test those. And so what I'm gonna try to do now is try to get our homing sequence set up. That way it'll go boom like that, get that angle, and then go boom like that and get that angle, and then go out to a special point that we have set. One thing I did notice is I think this one can also have the same problem as before, where it gets caught like that and then gets stuck. And I think it's because of these arm lengths right here. They're close to the same size as these arm lengths here. And as you can see, they go out pretty far, which allows us to draw far. But if it goes too far in like that and this thing slips back, then it gets caught. I think I'm gonna go and shorten these down. I'm just gonna go and remake some, but a little bit shorter. And then hopefully we won't have that problem where it's getting caught like that. That's kind of ridiculous. But yeah, I'm gonna go get these things shrunk down, and then I'm gonna start working on a homing sequence. All right, guys, it's Thursday. This morning I went ahead and swapped out both of the L1 arms so that they're now shorter. I also went and set up all of the auto homing stuff, and it's pretty reliable. I say pretty because sometimes it does fail. For some reason, the right motor has a problem where it'll start spinning the opposite direction that it needs to spin. I'm not entirely sure why that's happening, but I'm gonna look into it some more. Now, along with the auto homing, I also went and set up a shape for it to draw. Boom. So yeah, that's supposed to be a square right there. It is a little jerky, and I think that's probably because of our pen setup that we have. The pen is only really stable on the top L2 arm. I need to develop some sort of setup that allows us to connect our pen better to it. What I wanted to try to do this week was take one of these servos from our old design right here and add it onto here so that we can move the pen up and down. However, I just didn't get enough time for it, so we're gonna have to try to do that next week. Also, since we added the encoders inside of each motor right here, we're actually starting to get a lot more accurate readings. For example, this was a rectangle that the robot drew last week, and I had it basically just do this loop of drawing the same rectangle. However, it started to move the rectangle down to the bottom right here, and that was just because it thought it was in the same spot. However, the readings were just being thrown off every loop iteration. I tried to recreate the same thing with this new design here, and as you can see, there is no shifting to one side. It seems to stay in the right spot, and that's pretty good. Now, even though we have the encoders in here, I don't have the code set up yet to automatically recorrect where it should be. For example, with how it works right now, it will take the angle that it's at and the angle that it's got to get to, and then calculate the steps needed to take to get to that angle. And then it'll start just going through those steps. But with this setup, it could sometimes skip steps, which means we could fall short on the angle right there. And right now it doesn't even know that. It just knows that it got through all the steps and then it stops right there. And so what we need to do is have some sort of check at the end to see if it's at that location. And if it isn't, add more steps to the thing. But yeah, we'll get into that next week, hopefully. So yeah, there's still a few things that I've got to go and add to this thing. Anyways, I'm sorry if this video is a little bit shorter. I tried to cut out a lot of the repetitive testing stuff. I'm trying to get a good balance between including those and also including the real meat and potatoes of it. There was a lot more stuff I wanted to get done this week. Unfortunately, we did not get them done. But we did get the main robot build for version 4 done, so I'm pleased. Next week, I definitely want to attack the pen area, get that to be a little bit more stable, maybe add a servo to it to make it go up and down. That would be pretty dope. I'd also like to try to get the angle thing that I just explained where it auto corrects the angle and stuff set up, but I don't know if I'll get around to that. What I really want to add is a UI on my computer for this. I think it'd be cool if I could just tap dots on a grid and then have it automatically draw the lines between it, do the linear interpolation, all of that stuff, and then send the points to the robot. I might switch out from having the inverse kinematics be done on the robot to having them be done on my computer, and then my computer would just send all of the angles that it has to go to. That would maybe save a little bit of time on the ESP32. I know it's pretty fast already, and I'm going to try to see if I can get it to be a little bit faster. Ultimately, I want to get it to where I can upload a picture and then have it kind of decode the picture and then sketch out the picture on paper. I think that'd be a good like final product version for this. Not product, but you know what I mean. The wire mesh is still huge. It's actually even bigger now. I tried to organize it a little bit, but it's still kind of crazy. We might make a custom PCB for this, but I'm gonna have to see about that as well. Anyways, I hope you guys enjoyed this week's video. If you like it, make sure you hit that like button down below and even subscribe if you want to. With that, I'll see you guys all next week.